Okay, so hello guys, now we are going to the next tutorial 5. So in tutorial 5, we're actually stepping into the next chapter. The next chapter is basically kinematics, or kinematics of rigid body. So we are no longer dealing with kinematics of particles, we are dealing with kinematics of rigid bodies. So for kinematics of rigid bodies, there are actually a few important concepts understanding, but the equation is actually extremely simple. So the only two equations you need, for this part, for tutorial 5, the only two equations you need for tutorial 5 is actually VA is equals to VA slash V plus VB. And the other equation is acceleration of A is equals to acceleration of A with respect to B plus acceleration of B. Now, this might seem very simple, but it's important for us to really understand what does it mean by these equations. So, first of all, I want to start by trying to answer a few of the questions there. How do we apply this equation? Now, first of all, this is something that I want you to remember it for the rest of this semester until you have an exam. So it's very interesting. So today we are solving kinematics of rigid body. So it means the motion of a rigid body, which is a two-dimensional object. Now, it is important to note that when we talk about motion of rigid body, what we are trying to do is trying to solve the velocity of different points on the body. Because on the body itself is formed by how do I say? So a body itself is formed by different points, right? When the points add up together, it becomes a body. So it means that for a single body here, for example, each point can have different velocity. Each point can have different acceleration, so we don't know. So this equation here allows us to relate, now this is important, this equation here allows us to relate 2 points on the same body. Now I cannot stress this enough. This equation is only useful, is the most useful when we are trying to relate 2 points on the same body. If it's 2 points on different body, you need different equation. But when it's 2 points on the same body, which is what we learn now, you need these 2 equations. It will be very simple. Why is it so? You see, because when you are relating 2 points on the same body, let's say point A and point B, both of them are on the same body, it means that the relative velocity and the relative acceleration will be a circular motion. Why is it so? Because if 2 points are on the same body, it means that the distance between them is always fixed. When the distance between 2 points is always fixed, it means that the only relative motion that can be registered is a circular motion. In other words, if A and B has a fixed distance from each other, the velocity of A with respect to B in B perspective is a circular motion because it's a fixed distance, so I can only go in circular motion, right? In other words, the acceleration of A in B perspective is also a circular motion acceleration. So it makes things quite simple in this case. So in other words, we can straight away say the velocity of A with respect to B is equals to what? It's actually equals to VA slash B, which actually equals to R omega, right? And R is RAB. So let's say you want to find the velocity of A and B perspective. It's actually just this line here, RAB, which wouldn't change, and times the omega, which is actually the angular velocity of the whole body itself. So then the question is, what is the direction? What is the direction of this y is equal to VA slash B? It is actually either in this direction or this direction, depending on the rotation of the body itself. If the body rotates this way, this is the VA slash B. If the body rotates this way, this is the direction of VA slash B. But it must be perpendicular to the radius. That is the most important understanding. So VA slash B, let me repeat, VA slash B is the velocity of A in B perspective, and it is always perpendicular to the radius, in other words, the RAB, the distance between them, and it can go in both directions, depending on whether omega is clockwise or counterclockwise. Now, for details on how to look at the direction and stuff, I will cover when we start to do the questions, okay? But now, just have understanding that VA slash B is a circular motion, most important understanding. Now, how about AA slash B? Now, AA slash B is actually the acceleration of A in B perspective. Let me repeat again, I cannot stress this enough. A and B must be on the same body. If they are not on the same body, it means that you cannot. This equation you still can use, still correct, but it's just not very useful. It's only useful when it's on the same body, because when both points are on the same body, you know that the relative terms are actually circular motion terms. And you also know that acceleration of A with respect to B is a circular motion term, and a circular acceleration can only have two different components, right? You have a tangential acceleration and a centripetal acceleration. For the tangential acceleration component, it just equals to RAB, which is the radius between them, times the distance between them, times alpha, alpha being the angular acceleration of the body itself. Right, the direction, we'll deal with it later, plus AC. AC is the centripetal acceleration, which is actually just RAB times omega squared. And the direction, we'll deal with it later. So for RAB alpha, the tangential acceleration, the direction is basically in this direction or this direction. Doesn't matter. Why? Because AAB means acceleration of A in B perspective. In B perspective, A is going in a circle. So the tangential acceleration of A is either in this direction or this direction, depending on where is the alpha. Where is the alpha of the body? If the alpha body is like this is the tangential acceleration of A with respect to B. Now the centripetal acceleration though is always pointing towards the center of rotation. In this case, if it's acceleration of A with respect to B, B is the center of rotation because B thinks it's not moving, A is going circles about him. So B, this acceleration of the centripetal acceleration has the direction pointing towards the center of rotation. Very important. So from this thing, we can know that this is an additional information that's provided to us when 2 points are on the same body. Now, another most important understanding was that it is important to know that one single point can simultaneously belong to two different bodies. For example, let's say I have a hinge. Let's say this hinge and this bar here. If I'm connected by one hinge here, this hinge here is a point A. This point A belongs to this body, it also belongs to this body. In other words, if I have a point here B and a point here C, point A can relate with point B with this equation, and point A can also relate with point C with this equation. However, it's important to know that point B cannot be related with point C with this equation. I mean, you can, it's still correct. Technically speaking, it's still correct. Theoretically, it's correct, but it is not useful because we do not know the relative relationship between B and C. However, we know the relative relationship between A and B and A and C because the relationship between A and B is a circular motion. The relationship between A and C is also a circular motion. So that's the one thing that we can exploit when we know that 2 points are on the same body. Now, let's take a look at other tutorial questions and then we will try to see if we can answer more of it. If you have any question, please come and WhatsApp me. Thank you.